Hello guys, welcome back to my channel. Please remember to like and subscribe. Now today we're going to look at evaluating limits. We're looking at a set of past paper type questions that involves limit to infinity. So we have three questions here, A, B, and C. You can pause the video, go ahead, attempt them, and then you can come back and watch the solution. Now for a rational function to evaluate the limit to infinity, we divide the entire expression by the highest power of the variable in the denominator. And in this case, the highest power of the variable is x cubed. So we're going to divide every single term by x cubed. So we're going to have the limit as x tends towards infinity of 3x cubed over x cubed plus 5x squared over x cubed plus 7 over x cubed all over 4x cubed over x cubed plus 6x over x cubed plus 10 over x cubed. Now we can simplify this expression, so I'm going to have a limit as x tends towards infinity of 3 plus, and if we look at 5x squared over x cubed, by laws of indices, when we break that down, we're going to end up with 5 over x plus 7 over x cubed all over 4 plus, of course, x over x cubed would give me 6 over x squared plus 10 over x cubed. Now we can try to substitute the infinity in there. So this is going to give me 3 plus 5 over infinity plus 7 over infinity cube all over 4 plus 6 over infinity squared plus 10 over infinity cube. Now, of course, once we divide a constant by infinity, it is naturally going to tend towards 0. So we're going to have 3 plus 0 plus 0 all over 4 plus 0 plus 0, which is really 3 over 4. Now, what deduction can we make from this? Let us go back to the original expression. So if you notice in this expression, the highest power of the variable in the numerator was x cubed, and the highest power of the variable in the denominator is also x cubed. So we can actually determine what the limit is going to be even before we do the question. The limit of this will be equal to the coefficient of the highest power of the variable in the numerator, which is 3, over the coefficient of the highest power of the variable in the denominator, which is 4. And this only applies when the highest power of the variable in the denominator is equal to the highest power of the variable in the numerator. So this is equal to 3 over 4. When we look at question B, the highest power of the variable in the denominator is squared. So we're going to divide all the terms by x squared. So this is going to become the limit as x tends towards infinity of x over x squared plus 4 over x squared all over x squared over x squared minus 8 over x squared. So we have the limit as x tends towards infinity. Now when we break this down by using laws of indices, I'm going to get 1 over x plus 4 over x squared all over 1 minus 8 over x squared. Now if we substitute infinity, I'm going to have 1 over infinity plus 4 over infinity squared all over 1 minus 8 over infinity squared. Now once again, we say once we divide a constant by infinity, then it's going to tend towards 0. So I'm going to end up with 0 plus 0 over 1 minus 0, which ultimately breaks down to give me 0. So what can I say about this now? Now notice if we look at the highest power of the variable in the numerator, it was 1. The highest power in the denominator was 2. So the highest power in the denominator is more than the highest power in the numerator. And whenever this happens, the limit will always be 0. Let us now look at question C. If we examine the denominator, the highest power of the variable is 1. So we're going to divide every term by x to the 1 power. So we're going to have limit as x tends towards infinity of x squared over x plus 5x over x plus 1 over x all over 2x over x plus 6 over x. This is going to become the limit as x tends towards infinity of x by laws of indices plus 5 plus 1 over x all over 2 plus 6 over x. Now we can input infinity. So this becomes infinity plus 5 plus 1 over infinity all over 2 plus 6 over infinity. And remember we say once you divide a constant by infinity, it's going to tend towards 0. So we end up with infinity plus 5 plus 0 over 2 plus 0. Now, of course, if I add a constant to infinity, it will still be infinity. And if I divide infinity by a constant, it is still going to tend towards infinity. But let us examine this question now. Notice the highest power of a variable in the denominator is actually less than the highest power of a variable in the numerator. And so it turns out that in a scenario like this, the limit as x tends towards infinity will always be infinity.